Okay, chapter 11 deals with the chemistry of carbohydrates. And by the end of this chapter, okay, so we got three slides here of things that we should be able to do by the end of the chapter. Describe the four major functions of carbohydrates. Well, that's going to be in this video. It's section 11.1. Also classify carbohydrates as monosaccharides, disaccharides, or polysaccharides. We'll do that in this video as well. Identify chiral carbons. So we're going to talk about stereochemistry and chirality. You should be able to draw pairs of enantiomers. So I'll teach you what an enantiomer is, a non-superimposable mirror image. Use Fisher projections to represent DNL enantiomers. Identify functional groups like hemiacetal, hemiketal, acetal, and ketal. Draw Haworth projections of carbohydrate anomers. So I'll teach you what an anomer is. Classify monosaccharides as aldoses or ketoses. That's pretty straightforward. We'll look at that in section 11.4. Classify monosaccharides according to the number of carbon atoms they contain. Describe uses of four important monosaccharides. Describe the purpose of the Benedict's test or Benedict's reagent. Identify glycosidic linkages in carbohydrate derivatives. Describe the uses of three important disaccharides. So we'll look at some disaccharides. Describe the linkage in a disaccharide, right? Reactions for the condensation and hydrolysis of disaccharides. Describe the uses of three important polysaccharides and describe the linkage in a polysaccharide. All right, so we got a lot of work to do in chapter 11. So let's get started with carbohydrate structure and function, section 11.1. Now, if you're wondering what a carbohydrate is, structurally, a carbohydrate is a polyhydroxyaldehyde or ketone or substance that yields these kinds of compounds upon hydrolysis. And an example of a carbohydrate is this molecule here. This is ribose, okay? And you can see that ribose has an aldehyde in it, right? You see there's an aldehyde here in ribose, so aldehyde. And then it says here polyhydroxy, okay? Well, are there some hydroxy groups in ribose? The answer is yeah, there's one here. There's another one here. So one, two, and you can see there's a third one as well. Now, the name carbohydrate it's kind of a historical name, but if you look at the structure of, or the formula of glucose, glucose is, I'll just scribble it down up here. It's C6H12O6. There we go. So you can see that that's the molecular formula of glucose. It has 6 carbons, 12 hydrogens, and 6 oxygens, but its empirical formula would be CH2O, right? If you divided the entire thing by 6, you'd get 1 carbon, 1 oxygen, and 2 hydrogens. And that's where the word carbohydrate came from, because the first carbohydrates that were discovered had one water molecule for every carbon. Now, this is not true for all carbohydrates, but that's the history behind the name. And some of the functions of carbohydrates in living organisms, and you and I are living organisms, are to provide energy through their oxidation. So if you think about the human body, it's kind of like a big combustion chamber, right? Food goes in, you oxidize the food, you extract the energy from it, and of course, not only does it release energy, but it releases heat, right? So this is why you maintain your body temperature to supply carbon for the synthesis of cell components. We saw that carbohydrates contain carbon, right? You can see ribose has one, two, three, four, five of them. So carbon for synthesis of cell components to serve as a stored form of chemical energy. So it's one of the ways we store energy in our bodies, and then to form a part of the structural elements of some cells and tissue. So I'm sure that some of you have studied things like the phospholipid bilayer of a cell membrane. Well, sometimes you'll find carbohydrates embedded in that phospholipid bilayer. The figure that they've shown here, figure 11.1, shows you some foods that are rich in carbohydrates like bread and pasta and rice. Now, how do we classify carbohydrates? Well, you can see here we've got monosaccharide, disaccharide, oligosaccharide, and polysaccharide. A monosaccharide is a simple carbohydrate consisting of 3 to 6 carbon atoms. And some monosaccharides that you guys would know would be things like glucose. Glucose is a monosaccharide. Plus, if you've ever read any kind of food packaging labels, you'll see oftentimes foods will have fructose in them. So glucose and fructose would be monosaccharides. Next, we have disaccharides. And you can imagine that a carbohydrate that's formed from the combination of two monosaccharides gives you a disaccharide. So you bring two monosaccharides together, you get a disaccharide. Um, Probably the most common example would be sucrose. So sucrose, which is table sugar. So table sugar, okay, is sucrose, and it's made from glucose and fructose. Then we also have sugars like lactose. Lactose is a disaccharide, so that's made from glucose and galactose. So lactose, and I'm sure some of you maybe know somebody who's lactose intolerant, right? So sucrose, lactose. I'd say another one would be maltose. Maltose. Anyhow, oligosaccharides aren't going to come up all that much, but basically, when you have 3 to 10 monosaccharides linked together, you get an oligosaccharide. And then polysaccharides is when you have many monosaccharides linked together. So carbohydrate formed by the combination of many monosaccharides. And some common polysaccharides that you would know would be things like starch. Okay, so starch is a polysaccharide. Also glycogen. Glycogen would be a polysaccharide, and cellulose. So cellulose would also be a polysaccharide. And you can see this figure that they've put here on the screen. A monosaccharide, one sugar or one carbohydrate molecule. Disaccharide, you have two of them linked together. An oligosaccharide, somewhere between 3 and 8 linked together. And when you have many, many, many linked together, you get a polysaccharide like starch.